In this video, we're going to be looking at two measures of center, the mean and the median. Now, first of all, we can display our data either using a list or some kind of graph. So for instance, if we ask 7 friends how many pairs of shoes they own, here's our list of our results. And one way to make a graph of that data is a dot plot. We'll just draw an axis, and we'll put a scale on that axis that would include all these numbers, but we will not skip from 2 to 4. We'll include all of the possible values down here. And put a label on it. For each number in the list, we'll put a dot above the corresponding number. And there is our dot plot. Graphs are a great way to show the distribution of a set of data. Now, center describes a typical value of a data set. Two measures of center are the mean and the median. Well, the mean, which we sometimes abbreviate as x bar, is the average value. Now, to find the mean or the average, we find the sum of the values, or we add them all up, and we divide by how many there are. Well, here we need to find the mean of the data displayed in this dot plot. All right, well, just remember, each dot is a data point. So in other words, there are two 68s. So when we're adding these numbers up, we would have 68 plus 68 plus these two 69s here, and these 70s and all these 71s and all these 72s and all these 73s. Instead of writing all that down, I'm just going to put a little dot, dot, dot. In other words, we continue adding all of these. And I'll finish up with those last 73s there. All right, so we add all the values and then divide by how many there are. In this case, there are 17 dots, or 17 data points. All right, when we add all those up, we get 1,203. And when we divide by 17, we get 70.8. So our mean is 70.8, or we could say that equals x bar. Often we just have a data set. So to find the mean of these numbers, we can just add them up and divide by how many there are. So the mean of this data set is 6. Now, an outlier is an extreme value that does not fit in with the other data. Let's do a little investigation about the effect of an outlier on the mean. So first, let's find the mean of this data set. So I'm going to add all these numbers up and divide by how many there are. So instead of writing all of them, I just put dot, dot, dot to indicate that we're going to continue adding all of these. All right, the sum of all those values is 336. And when we divide by 7, we get 48. All right, now we're going to find the mean if one instance of the value 964 is added to this data set. So we're going to add up the same numbers, but we're also going to add in a 964. And now there are 8 values, so we're going to divide by 8. When we add 964 to this previous sum, we get 1,300. And when we divide that by 8, we get 162.5. Take a quick note of how that compares to the previous mean. And did the outlier have a strong effect on the mean? Well, it sure did. The mean changed quite substantially when we just added this one value. Now, the summary here is avoid using the mean when there is an outlier. We say that the mean is non-resistant to extreme values. It does not resist those extreme values. It gets drawn towards it because of the way the formula works. Another common measure of center is the median, and it's the middle value when the data is ordered from least to greatest. That's an easy one to forget, so remember when you're finding the middle value is meaningless unless we've put the numbers in order from least to greatest. All right, now the middle number is sometimes the actual middle number, but sometimes if there's an even number of values in the data set, there's not one middle number, there's two middle numbers. So in that case, the median is the average of those two middle values. All right, we're going to find the median of these numbers. So first, we put them in order. And we notice that the middle number is 10. So the median is 10. Okay, here we have another data set, and we're going to find the median. This time we'll have two middle numbers. All right, so our median will be the average of these two middle numbers, or halfway between. Now the procedure is to add those two middle numbers and divide by 2. Now sometimes we can figure out the middle of the two middle numbers without actually doing the calculation. But let's go ahead and go through and calculate that. 13 divided by 2 is 6.5. Halfway between 6 and 7 is 6.5. That's what we just calculated. So in this case, the median is 6.5. So if there's one middle number, that's the median. If there are two middle numbers, we add them and divide by 2. All right, let's investigate the effect of outliers on the median. Previously, we saw that the outlier had a strong effect on the mean. Let's see what happens with the median. All right, first we'll find the median of this data set. In this case, there's one middle number. So the median is 48. Now we're going to add an instance of the value 1112 to this data set. So same data set, we just have an extra number. And we'll find the new median. So our median, our new median, will be halfway between 48 and 51. So we'll go ahead and add those and divide by 2. And we get 49.5. Now we notice that even though this outlier was way larger than the other numbers in the data set, it really did not have a very strong effect at all on the median. It increased a little bit, but not much. So no, the outlier did not have a strong effect on the median. So to summarize, when measuring the center of a data set containing an outlier, use the median. Now the quartiles are related to the median, and the quartiles break the data set into quarters. The first quartile, or Q1, is the middle of the lower half of the data. And the third quartile, or Q3, is the middle of the upper half of the data. Now, you might be wondering what happened to the second quartile. Well, that has a different name. It's the median. Now, the first quartile is like the median of the lower half of the data, and the third quartile is the median of the upper half of the data. Let's give it a try. So we're finding quartiles. We will first find the median, and then we'll find the middle of the values to the left of the median, and that will be the first quartile. Now notice we are not including the median when we are finding the first quartile. It's everything to the left. And then same thing for the third quartile, but we're finding the middle of the values to the right of the median. So let's find the first quartile and the third quartile in the following data sets. So I'll put the numbers in order from least to greatest, and then find the median, and then I'll find the middle of the lower half of the data. That'll be first quartile. And then I'll find the middle of the upper half of the data, and that'll be the third quartile. Right, in this data set, there is one middle number, it's 18. So that's the median. And when we look at the numbers to the left of the median, so we're not including the median, there is again one middle number. Now, it won't always be the case that the first quartile will be one particular number. Sometimes you'll have to add them and divide by 2. But in this case, we see that 7 is the first quartile because it's the middle of the lower half of the data, or the median of the lower half. Looking at the numbers to the right of the median, we see that the third quartile is 26, the middle of the upper half of the data. Let's do that one more time here. Going to find the quartiles by first putting the numbers in order, finding the median, then finding the middle of the lower half and the middle of the upper half. All right, in this case, there are 2 middle numbers, the 21 and the 23. So the median will be halfway between those. And we can always add and divide by 2. And when we do that, we get 22, which notice is halfway between 21 and 23. All right, now the middle of the lower half of the data, notice we're not excluding anything. Remember up here, the median didn't get counted in either the lower half or the upper half. But in this case, we have the entire left half. And once again, we notice there's one middle number, but it doesn't have to be that way for the quartiles. The 17 is the first quartile, and 28, which is the median or middle of the upper half of the data, is the third quartile. All right, the 5-number summary requires 5 important numbers. The minimum, which is the smallest number, abbreviated as min or Q0. Then we have the first quartile, the median, the third quartile, and the maximum, or the largest value, which we can abbreviate as max or Q4. All right, we're going to go back to those previous examples and write the 5-number summary. See that the smallest number is 1, so we'll say min equals 1. And we have the first quartile, and we have the median, and the third quartile, and the maximum. And there's our 5-number summary. And this 5-number summary is an important way to help us understand a data set. We'll do that one more time. So we have our minimum, first quartile, our median, our third quartile, and our maximum. And there's our 5 number summary. I hope these examples have been helpful. This is Mr. Ela, signing off.